Okay, welcome back to the snake game part 5, I think 4 or 5, I'm not so sure. So this is going to be our last video of this series, and we're going to wrap things up. We're just left with a few things. We have to add some obstacles, and we also have to add some speed into the game so that the snake moves fast, and we also have to make the snake die in a way so we can make use of this game over variable here. So we have to first, let's just create the obstacles that spawn around to make the game more challenging, to make it more exciting. So um, let's try and do that. Let's add some difficulty levels by creating an obstacles function. So let's create an obstacles function. Okay, so in this function, what we're going to make use of the random object generator like we did with the with respawning the food, but this time we're going to be displaying ob or obstacles, should I say, obstacles popping out onto the screen, and we're also going to make them pop off of the screen. And this is going to be just done in random time. We don't know, we can't set the time, so I'm just going to randomize things here. So I'm going to show you how I do it. I'm pretty sure there are other ways to do it, but this is how I came up with the solution. And so we're going to create what's known as a hash map at this point, because we're going to try and put these obstacles in a list, but we're not going to use a list. We're just going to use a hash map because it comes with some advantages. So let's declare it. Actually, we're going to use something called a concurrent hash map instead of just a hash map, because we're working with threads, and threads can cause some few problems there and there. So we're going to use a concurrent hash map. It's thread safe, and we're going to eliminate some problems here. So just bear with me with the concurrent hash map. Concurrent. My spelling isn't the best. Let's import it. Okay, so what the concurrent hash map does is it works almost like an array or a list, but it's kind of special. Instead of referencing it by index, you can reference it by a key. At this point, a string. We're going to make strings the keys for every single obstacle, so we can be able to delete it. We can be able to know which one we want to pick out. So it will eliminate future problems that lists tend to have, or arrays tend to have. So let's initialize it. Let's borrow this from Eat Food. Like I said, we're going to be using this random object. So let's create X and Okay, so this is what's going on. Um, like I said before, we are trying to just randomize these things. So we're creating like a timer, right? And this timer is going to range from 0 to 199. So within whatever numbers this timer gets, whenever it reaches 14, we'll generate one block. Whenever it reaches 28, we'll generate two blocks. And whenever it's 100, we'll delete an obstacle. So, yeah, so now what we do is we create some obstacles. Like we respawn some obstacles like we did here with the eat food. Okay, like I explained on the eat food function, this 40 is like a range, is from 0 to 39. So get us uh, any coordinate from 0 to 39 and then times it by 10. So what we will do, first let's just create the y's and the x's. Right. So we're going to, first and foremost, I made a simple mistake. This hash map is going to take an array of an object because we also want this object to have more than one block, so that, like we did here, we said generate two obstacles. So it can generate one obstacle, it can also generate two. So we're going to have to put these objects in an array. So let's, if the timer is 14, then we just need one block, one array. So let's create that. Okay, so this key, this variable here that we have to put, we'll have to put a string. We could use an integer object, but we don't want to use, I don't want to use int here for a specific reason, because mostly performance reasons, because I tend to like to use characters or strings because they don't take a lot of space. You know, a character is just a byte, and it 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 makes things, it makes the performance much better when you use characters or strings instead of ints. So we're going to use a string here. The way we'll do this is we're going to use the size, the new size of the map as the key at this point, and we're going to have to convert this int into a string. So what we do, how we do that is we use an integer object. Okay, so we put this, the key, as the number. So if it's one, instead of being an integer one, it's going to be a string of just the character one. So that's all well and good. Now this, we did this for just generating one obstacle. Let's do this for generating two obstacles. It's going to be almost the same, but a bit different. So just look out for that. So let's, okay, we're going to, instead, we're just going to, this is going to only take a maximum of 2 elements and right. All right, so whenever the timer gets to 28, we should be able to see like a longer block. If it's only 14, then we should just see like one square. But if it's 28, then it should make like a horizontal kind of square, meaning there are 2 blocks on it. So just to make it more interesting, make it more challenging, and we'll also have to delete the obstacle. But for now, let's just test it out and see if it's working. Hopefully we'll see some ways, trace and logic. Oh, before we haven't yet drawn it to the paint component. We have to draw it. We have to make it visible. So this is where we make things visible, like as usual. So we're going to use, because we're using a hash map, and hash maps, we're going to use an advanced for loop. Instead of a regular loop, because we're working with keys here. Okay, now because this gets an array, we're going to create another for loop. Let me just copy these for loops. They're so annoying to type. Let's give the wall, or should I say the obstacles, the color white, so it stands out. Um, let's make it feel rect instead of feel oval. We want a square. We want it to look like a wall, so hopefully, let's hope. We should see things popping out randomly. Hopefully it doesn't make me look bad. Okay, we see one thing, we see the other, but these are usually just one block. I want to see if a horizontal block will pop out. Still one block, it's okay. Okay, so we see one below. It's more taller. I mean, the width is much more than these other ones. So yeah, we're having some randomized obstacles just popping around, like those difficult snake game levels. So yeah, it's cool. But we're able to go through the obstacles. Later on, we're going to create a function that is used to end ourselves if kill the snake if it reaches the wall. So this is good. Now we're going to have to need to delete them, because if we don't, we don't want to saturate our screen with just white blocks, and we have to make space. We have to delete them. So how we delete is quite simple, because we already used the hash map and we've given it a key of a string, which happens to be its size at this point. What we're going to do is we're going to use this random generator. Okay, so we're going to take the size of the map and we're going to put it as a range of our random generator, meaning that we need you to generate any numbers from 1 to the map, to the size of our maps, and whatever number you get, hopefully it belongs in one of our hash map. Delete it, remove it. And so this is how we're going to do this. We're going to use a while loop first and then a for loop. So we're going to use, let's just create a little boolean. Okay, so we're looping through checking if um, we have gotten a result. So we take this size, right? First, this size needs to we need to put this inside the while loop, because it's going to be changing. If it doesn't find anything, it has to regenerate and try to pick another number. So We're going to check. First, we're going to make this a string, right? First, let's just make it a string, because that's the key. The key is a string, but we're first getting it as an int, and then we'll have to use this. We have to convert it into a string. To convert an int to a string, you use an object called integer, then .toString. You can even pass a string, so it's a pretty cool object. I use it a lot. Okay, so let me just add some space to clear things. Right, now, once the timer reaches 100, right, we're going to take the maximum number of the size of our map. Then what we're going to do is we're going to put it in a random generator. Then we're going to tell it start from 1 to that maximum number. So just know that from any of this range, our key will be available here. Because whenever we create obstacles, we give the key as the new size, or should I say the new number of the amount that's in this map, in this hash map. So that's what we're doing. Whenever we get a valid response here, whenever they're equal, it means that, break through the loop and remove the map and remove the let's remove. Right, so this should work, hopefully. As objects spawn around, they should be popping off on their own automatically. Let's see. Hopefully it doesn't take too long, because these things take a bit. Where are your friends? Where are some of them? Just one. Come on, don't do this to me. Obstacles. Okay, there's that one. Okay, they're popping off. They're popping off. Looks like when one pops off, the other pops off. There's a bit of a problem here. Let's see what I did wrong. Okay. Problem. Well, so I figured out the problem. We have to make sure that this is greater than 0, the size, because if it doesn't have anything to check on, it will lead to problems. So before the while, let's make sure that it's greater than 0. So right now, what we'll have to do is, you see, this is getting any number. Now, as we delete these, as these these obstacles get deleted, some numbers don't become valid. So we don't want to have to get a number that's invalid. If this is null, then it doesn't work. It will just get stuck. So we want to avoid this. So what we can do is we first check a key. Check the key. If it exists, if it doesn't, if it exists, just break out. If it doesn't, continue. So all right, hopefully, please. They seem to be they seem to be popping and popping out, but I don't like the effect of having one to pop out then the other pop in. But I'm pretty sure that's just because the frames are going too fast. So maybe. Okay. See, I don't like that when the obstacle, you see, like it comes out, then pop, then, I don't know what that's all about. I hope it stops that. Okay, this is not what I want. What's going on with you? Okay, look, this looks like much better compared to the earlier. I think that just because things are so random, sometimes they don't appear at all, sometimes they appear pretty fast, and these are just some things that you have to be mindful of. But it works. It seems like things are just responding and popping out on their own. Well, so far so good. I can't complain. Um, let's continue the game. Hopefully things get better as we go. Looks like continue probably did the trick. Let's just try to increase the speed of the snake as we eat. This is going to be quite easy, actually, the easiest part. To be honest, the obstacles part is probably the most complicating for a newbie. To be honest, if you're a newbie, I hope I explained things much better. But yes, hopefully, it can make sense to you the way I've explained things. So maybe this is going to be the part that's the most complicating in this game, but when we move to increasing the speed, I think this is going to be easy. So we have to look at the game loop here. We have to look at this guy over here, 120. Now, if we increase, let's say, let's put it to 20, right? Let's change it to 20 and let's play the game. It's fast. It's super fast. Oh, so this is how we change the game, the speed of the game. We're going to use a variable. Let's, we haven't created this variable yet, but we're going to create it. We're going to create it. Now this speed is going to start at 120. That was the normal starting speed that we had. And every single time we eat the food, right? Always eat food. Every time we eat the food, we subtract by 5, right? Let's take, let's just subtract by 10. So every single time the snake grows, the speed increases. I think you can start seeing the difference as we start eating the food, that the speed of the snake is increasing. So, yep, it's increasing. This makes the game much more challenging. I think 10 is a little bit too much, right? Okay, let's, instead of putting it 10, let's give it 5. That way we don't, it doesn't become too much. So, now these obstacles are no good if we cannot bump on them and die, right? These are meant to make the game more challenging. We have to make the snake, we have to make the game over or variable work at this point so that whenever we crash our snake or we crash the obstacles, then it becomes game over. So we're going to first start with the snake. At this point, the obstacles seem to now be behaving for some reason. You should have just been okay from the start. Obstacles, what's your problem? But it's okay. Yeah, let's, because you can see, like, when we try to go through the snake, nothing happens, right? We can't kill ourselves. Nothing happens. So we need to make sure that we can kill ourselves. So let's create a function called, let's crash snake maybe. And as is usual, we're just going to be creating a for loop here, go through the whole snake. Okay, so if this is true, we have to set the game over to false. Where's that game over variable? You are here. No, we have to set the game over to true, not false. Because the game, you must be okay now. Because the game, it starts at false. Now this game loops every time it's false. If it encounters that game over as true, this loop breaks and the game isn't running anymore. So let's see if this condition will work, because what we're doing is we are controlling the head, right? The yellow box. This is controlled by the head X and head Y coordinates. And we have to check through the whole, we have to start from the tail, the starting tail, and then we have to loop through all the tails to see if the head hits any of the tail. If it does, then it gives us this game over. Let's first grow the snake first. Let's make it long enough for us to be able to crash on our own tail. I think this is enough, right? Let's try now. No, it's not enough. And it's becoming fast, so okay, it's not crashing on the tail. The reason why it's not crashing on the tail is because I'm a bit clumsy, so I have to put this function in the trace and logic. I'm sorry. Let's put it here. It shouldn't be, it should be less than tail. Okay, let's grow our snake real quick. Let's see if we can now kill ourselves. Okay. As you can see, we bumped into our tail and it's game over. It stopped playing. So it's working. Hitting our tail is working. Let's make this snake start at a range, shall we? Instead of making it start at 1, let's give it at least 3. So that okay, why? Okay, it looks like hit tail has a little bit of a problem here. Let me see. Okay, so let's try and make the default movement to be down, because we seem to be getting what what is it called, a semantic error. You know, the logic of the game isn't valid with some kind of operations. You know, the snake moves from left to right and the head starts from left to right. So in other words, it becomes like the hit tail becomes valid. So it becomes game over. So we have to start from, let's make it move down as we set the snake, and let's breaks that. Okay, the snake starts moving down by default as we increased the size of the starting snake. So as we eat the snake, it increases by size, and okay, so that's all well and good. Let's also be able to hit the obstacles, right? Because obstacles spawn around and we have to be able to hit them. And the way we do that is it's just like how we did the hit tail function, but instead we're going to be looping through all the obstacles. So oh no, we're going to use a for loop, an advanced for loop, because we're working with hash maps. Okay, so we're going to, every single time we loop through this obstacles, we're going to look for the head X and the head Y. If they match, then it's going to be game over. Let's steal this for a little bit. Okay, so now we loop through all the keys of our hash map, which belong to our obstacles. We get the array and match if any of them hit, if any of our head hit any of the wall, the game over should be true. Okay, now as usual, I'm too excited. I forgot to add this and trace and logic. Let's just hit the wall and see. Oh, it disappeared. Come on, where's another one? Okay. Please, please, please. Oh yes, it works. Okay, so we've hit the wall and it's game over. That's good. So it makes the game challenging, right? Let's see. Let's see the second time. Hopefully, it's not going to give us any problems. Okay, so as long as you hit an obstacle, the game will be game over. Now, we've managed to kill ourselves through hitting our tail, killing ourselves through hitting the wall. Let's make some, I guess, some future problems, mistakes. You remember when we made this don't block tail, where the food has to respawn anywhere, but it shouldn't respawn anywhere near the tail? We'll have to create the same kind of logic for the obstacles at this point, because obstacles spawn anywhere and they could spawn around where our snake is, or they could also spawn around where the food is. So let's create this for the for the obstacle. Let's do this. Let's copy, because the idea is the same. We're just okay. So we go here on the obstacles. Whenever we create an obstacle, we have to check, right? Like we did in the food thing, we have to check through a do while loop. So we have to give it the coordinates of the obstacles, because we're checking. We have already checked the snake at this with this function, so we have to give it variables x and y's of the obstacles, because these are arrays now. I was expecting that, because you have to be cleared outside. Okay, do this while you don't appear anywhere on the tail. So we could do this for this as well. I think everything should work. So hopefully during the game, obstacles do not appear anywhere near the where the snake is. So um, right. So we have to also do this for the food as well, right? We wouldn't want the food to be hiding anywhere near the obstacles. So we also have to check if it is not, we have to respawn it as long as, or should we say, let's check the obstacles that they do not respawn anywhere next to the food, right? So let's try that. Um, let's add don't block food. And instead of looping through a snake at this point, we're not going to loop through anything. We're just going to use an if food X. Okay, so if the food is matching, it should return true, else false. So we could go back to our obstacles here. While do this and as well you. Maybe it's just some performance issues, probably. When I restart it, things become a little bit better. That was pretty quick. That was very fast. You could try and, instead of making these things um, appear very fast and come out and everything, you can set the range to be much higher than the one I set of 200. Yeah, so you could do that. So I think this will be, oh crap, I just hit an obstacle. So you see how fun it can be. So I want us to stop here. I think this is going to be the last part of the game. I've tried to explain as easy as I could. I hope most of you have got all the information quite clearly. So yeah, this is the snake game. It's an advanced looking snake game, like the ones that we always used to play back in the days, that challenged your mind. And so yeah, hopefully you can you know feel a little good about making this game. So I'm going to be posting, oh, that was something that, anyways, I'm going to be posting the rest of the complete code on my GitHub. I'll link it on the description, so whoever is interested can go check it out and play around with it. But as for now, I will say adios and till next time. Bye.